Welcome. So let's begin. Now we shall create our namespace, base64. So namespace, base64. And we will have all of our functions and variables inside of it, and we will refer to them when we call them elsewhere in the following fashion. So let me just go ahead and close this. And why are you doing this, for crying out loud? We will refer to these variables and functions later on, and we will call them so. So remember how we type in std and then type in, I don't know, string, or you can type in cout or etc. Well, this time we will type in base 64, and then we shall use something from it. I don't know, some sort of function. Let me just pick one up. So base 64 underline encode. So this will be an example of how this would work. This will be a function that we will make momentarily up there. And yes. For some strange reason, I've used capital letters here. It's lowercase letters. Oh, base. There we go. That's why I've used it capital letters. That's what. God, code blocks, or my brain, one of the two is not functioning. I'm casting a lot of tutorials today because I'm going on a trip, and I would really love to finish it all up for you, as a lot of people have asked me, and I've made some promises that I will try to publish it as soon as I can, so I'm doing my best here. Dying, but doing my best. Anyway, let's go ahead and declare a prototype. Let's create a prototype of a function. So std string base 64 underline encode const std colon string and percent sign. There we go. So nothing that we haven't seen before. It's a constant reference to a string. No big deal. We have mentioned it before a lot of times. That is the parameter that will be passed to our function here. This is a function that we're making. And down below, we will create a few salts. So let's say create 3 salts. What are these salts? Well, how shall I put this? They'll basically be our encryption and decryption keys. You can put it like that. I mean, it's not a very strict definition. It's a very liberal definition of it, but let's put it like that. You can take a look. You can type in on the net salts and have a look around. It's SALT, but you will see what we shall do with them, and in that fashion, you will understand what they actually are and what purpose do they serve. It is important to memorize them or to have them written down somewhere, because without them you will not be able to decrypt your file, as you will not be able to reverse the procedure which will be used to encrypt it. They're arbitrary, so we just type in something, I don't know, let's type in const std string and percent sign salt1. I'll have 3 here. You can have 10,000 if you want. Well, perhaps you shouldn't have 10,000 because that will make the file size humongous. Okay, so TB, I don't know, BB, whatever. This one has this format. Next one will have something else. So const std string again and percent sign salt2 is equal to underline something colon slash underline 77. Okay. So let's make it so. Where is it? Yep, there we go. And the third one, again, so const std string salt3. So as I said, I have 3 here, but you can have 100 of them or 10,000 or whatever. It's really up to you. And this one, let's make it weird. So line equals wow C++ for the win. There we go. So I have 3 of these, which we will use to scramble base64 encoding, and we will need to unscramble it later on. So we need some serious encryption, not the plain base64, as I have stated, for encoding and decoding as well. Plain base64, as I have stated previously, can be decoded within seconds on the internet or so. So what we shall do here is that we will triple encode it, but with some modifications between the encodings themselves, which will pretty much make it impossible for anybody else to decode without knowing what exact modifications have been implemented. The resulting string is about 3 times longer, which is a problem, but it is safer than plain base64 by far. Also, keep in mind that, as I've stated, you can use, from a technical point of view anyway, any sort of encryption that you want, like IS or whatever else comes to mind, and yes, they are far stronger, and yes, you can't actually, I don't know, maybe somebody has decrypted them, I'm not aware of it. Maybe somebody has cracked those encryptions, I'm not aware of it, but you can use whatever you want from a technical perspective here, pretty much. But it's rather complicated, and the external libraries are... that's bad. Anyway, have fun with that if you want it. If not, we'll use base64 and we will obscure the strings. Encoding, yes. STD. String. Encrypt B64. STD. Oops. String S. Okay, so sorry about that. Now, this is what we are about to do is completely arbitrary. It can be mixed pretty much any way you want, but we have to use the same salts and the same steps when decoding. So we have some string, and that string has been filled with our file that the keylogger has made. Let's just assume that we have it. We still haven't created all of that. So let's assume that we have a file, we have a string which is filled from the contents of the file which our keylogger has made. And now we're going to play around with that string. So we shall say that S, that's some string, is equal to salt1 plus S plus salt2 plus salt3. So you could have done this any way you wanted to. It really isn't important. Now we have scrambled it a little bit. Next up, we will go ahead and use base64 to encode it. Oops. We still haven't actually created the base64 encode function. We've just created a prototype for it. We need to create a body for it. We will do that later on. So now we will go ahead and encode this string. Base64 underline encode. And we will use that string. Okay, so this function is defined below, as I've stated. Now we can add another salt, but this time we will install the salt after the 7th character. Weird, I know. So s.insert, and let's go ahead and use the 7th character. Let's state the 7th position, or salt3. So this is purely arbitrary. I could have written whatever here. So salt 1 or 2, or I could have written, instead of the 7th position, I could have written the 10th position, etc. Even the order of these things is arbitrary. So there is no need for this line to be first. There is no need for things to be in this order in this line. There is no need to encode it in base64 here. You can switch it around, play with it, whatever. The more you obscure it, the more passes you make, the harder it will be. The harder will it be to decode. But I do believe that what was written now is more than sufficient to prevent any sort of decryption. I mean, yes, sure. I mean, some servers in the world could do it, or some sort of bug could be found or something like that. Sure, there's always a possibility, but from a standard user perspective, it is not very likely. As I've stated, if I encourage you to try to decode it, to decrypt it if you can. Please let me know and tell me how you did it and what happened, what were your experiences, etc. I'm most curious about that. Okay, so salt 3, and if we, let's go ahead and, I don't know, plus equals salt 1. Let's just add salt 1 to it again, and then, okay, so let's then state that S is equal to, let's encode it again. So base 64 underline encode, and let this be S here. So now that we have encoded it, let's go ahead and play around with it some more and more. Salt 2 plus salt 3 plus salt 1. S shall equal to base 64 underline encode, and that's going to be S. Excellent. Also, very important, a crucial step is that we mask this base 64 string, that no one is able to decode it with a regular base 64 decoder and find out that the decoded string is another base 64 string. So it doesn't matter if you just do base 64 100 times, somebody can decode it 100 times rather fast. You are with salts and these with our secret text, so to put it, we are adding the next characters we are destroying. With adding the next characters we are destroying. So a regular base 64 string, it is not valid anymore until characters are actually removed. So you need to take out the characters that we have added in an order in which we have added them, and only then would you be able to use base 64 decoding, which I suspect is no easy task, I can tell you that much, because you have no idea what we have added to it. Okay, so let's type in s.insert. At first position L, s.insert, I don't know, at 7th position M. There we go. There we it's happening, there we go. And finally, after we have done all of that, I shall type in return S. There we go. That will be our function for encryption. We will continue in the follow-up tutorial, not the follow-up chapter, where we will continue with this. But in any case, this is the basis of our encryption. So this part here, where you do a ton load of stuff to this string and insert arbitrary salts and then encode it several times over with base 64, so that nobody can so that it's really difficult to reverse it, or perhaps impossible. Well, nothing is impossible, but yeah. Anyway, bid you farewell, and I shall see you in the follow-up tutorial.